Hello and welcome. I am Rebecca Chow, a product manager at Microsoft. Today, we're focusing on a topic that can define success in the cloud era: performance. Performance isn't a luxury. It's a driver of customer confidence. It can accelerate innovation, and it can be the safeguard of business continuity. Whether you're processing millions of financial transactions, managing electronic health records, running real-time AI-enabled applications at scale, or supporting globally distributed applications, you need infrastructure that is high performance, reliable, and resilient. At Azure, we understand this deeply. That's why we continue to make significant investments in our infrastructure as a service IaaS platform to ensure your workloads can perform at their best, helping you meet your service level agreements, or SLAs. Now, how can you improve the performance of your workloads? In the next few minutes, we will focus primarily on data-intensive business-critical workloads. Let's break it down. To meet the unique end-to-end performance requirements that each of your workloads demands, the unique and diverse capabilities across compute, network, and storage are vital. Azure takes a comprehensive system-level approach that doesn't just optimize each component individually, but redefines how they work together holistically. This approach is powered by Azure Boost, a breakthrough innovation that accelerates performance across compute, network, and storage by offloading networking and storage tasks from the CPU to dedicated hardware. With Azure Boost, every new Azure data center is designed for predictable performance, stronger workload isolation, and unprecedented improvements in throughput and latency. It is the foundation that makes compute, network, and storage perform at their absolute best. Now, let's take a closer look at each pillar, starting with compute. For compute, we have introduced specialized VM families to meet diverse workload needs. For example, memory-optimized VMs like the EBS v6, EBDS v6 series are engineered to deliver higher remote storage performance, which is ideal for throughput-intensive workloads like relational databases and data analytics applications. This VM series can support up to 800,000 IOPS, 14 GB per second throughput. Intensive memory-optimized VMs like the MBS v3, MBDS v3 series are ideal for massive in-memory database workloads that can't be easily hosted on E-series VMs. These VMs can more efficiently support large in-memory databases like SAP HANA or other data-intensive workloads like electronic health records. Compute-optimized VMs, such as the F or FX series, are designed for computationally intensive workloads like EDA, batch processing, or gaming that demand high CPU to memory ratios. Cobalt 100 ARM-based VMs also provide excellent price performance for CPU-intensive workloads. One tip to share: for latency-sensitive group applications, Azure offers proximity placement groups, a logical construct to ensure VMs are physically located close together within a data center. This minimizes network latency and improves reliability for tightly coupled workloads. On network side, Azure delivers industry-leading network performance with ultra-low latency, high throughput, and technologies like accelerated networking and SRIOV for consistent results and direct access to hardware. Our new network-optimized virtual machines, such as DNLS v6 and DNS v6 series, offer enhanced network bandwidth, increased connection setup performance and flow limits, and additional virtual NICs that scale with vCPU, providing greater capacity than general-purpose VMs. These sizes are ideal for high-performance networking, scalability applications, and for network virtual appliance workloads that process a high number of connections or require more virtual network interfaces. They improve throughput capability between VMs, internal load balancers, and virtual network peering, both within and across regions. It's important for you to deploy the latest VM series within each VM family. That will ensure overall higher performance and significantly better generation over generation price performance. Finally, let's talk about storage, the backbone of your data in the cloud. Storage isn't just about protecting your data. It's also about scaling effortlessly and delivering the right performance for your applications. Here's a quick guide. Blob storage is an object storage solution designed for storing large volumes of data that is versatile for many workloads such as analytics, scientific computing, and AI. Blob storage accounts can scale to hundreds of petabytes of data, double digits of terabits per second storage bandwidth, and millions of IOPS. Azure Files is a fully managed file system widely used across enterprise workloads, hybrid developments, and VDI environments, delivering secure and scalable file shares with SMB and NFS protocol support. Azure Files can scale to hundreds of terabytes per share, provide multi-gigabyte per second throughput, and achieve up to 100,000 IOPS with low latency access for demanding applications. Azure Managed Disk and Elastic are block storage solutions that power performance-critical workloads for Azure virtual machines and other compute solutions. Managed Disk can scale up to 400,000 IOPS and 10 gigabyte per second throughput at sub-millisecond latency, delivering dedicated, predictable performance for mission-critical database and enterprise applications. Elastic SAN brings storage-attached network, SAN, flexibility to the cloud, pooling millions of IOPS and double-digit gigabyte per second throughput across multiple workloads to optimize total cost ownership while supporting diverse traffic patterns. Choosing the right storage type can help ensure your workload runs efficiently and cost effectively. One of the most common architectures for running these workloads on Azure combines virtual machines with block storage like Managed Disk and Elastic SAN. This approach provides flexibility, predictable performance, and integration with Azure's broader ecosystem, such as Azure Backup, Azure Site Recovery, making it a proven foundation for high-performance scenarios. Within Azure's block storage portfolio, you will also find options like standard HDD, standard SSD, and premium SSD. But when your application demands very high dedicated performance and predictable low latency, two offerings stand out: Ultra Disk and Premium SSD v2. These disk SKUs are purpose-built for scenarios where every millisecond, even hundreds of microseconds count. So next, we'll dive into what makes Ultra Disk and Premium SSD v2 unique, how they differ, and why choosing the right one can make a dramatic impact on your workload experience. UltraDisk offers up to 400,000 IOPS, 10,000 megabyte per second throughput, and consistent low sub-millisecond latency. Ideal for IO-intensive, latency-sensitive workload, such as top-tier transaction database, mission-critical financial platform, scalable gaming deployment, and AI applications. Premium SSD V2 provides up to 80,000 IOPS and 1,200 megabyte per second throughput with sub-millisecond latency at a more cost-efficient price-performance ratio that suits most general-purpose enterprise workloads. Both products allow granular performance tuning, but UltraDisk is the go-to for massive I/O scale and latency-sensitive workloads. We have covered the differences between UltraDisk and Premium SSD V2 in details, but the real impact becomes much clearer when you see how UltraDisk and Premium SSD V2 performance affect real-world scenario, especially when it comes to latency. Take healthcare systems as an example. Today's healthcare systems are driven by large databases and datasets that are critical to care delivery. Even minor delay in seconds or even microseconds can potentially compromise the quality of care and patient outcomes. For the largest and most demanding healthcare systems, where millions of patient records, diagnostic imaging, and real-time clinical decisions happening simultaneously, UltraDisk paired with M-series virtual machines is the recommended architecture. M-series virtual machines are built for compute and storage intensive mission-critical databases. Paired with UltraDisk that provide around sub-millisecond latency, even under extreme data loads like 100,000 of IOPS, ensures the clinicians experience the responsiveness they need. Without further ado, we will use a workload simulation tool to mimic real-world hospital operations to illustrate how UltraDisk and Premium SSD V2's latency profiles can affect healthcare organizations' electronic health record performance. Let's take a look at the demo.
For this demonstration, we have set up two systems running the same electronic health record EHR database simulation workload. Both systems are set up on our M176BS V3 virtual machine that supports up to 650,000 IOPS. One system with 10 UltraDisks configured at 65,000 IOPS, and the other system with 10 premium SSD V2 disks configured at 65,000 IOPS. We will quickly show how the two systems' performances differ when running under the same EHR database simulation workload. Now, let's take a look at disk utilization metrics on the PV2 disk, which are consuming up to 80% of the virtual machine IOPS, which is about 520,000 IOPS. On the UltraDisk system, we are achieving higher IOPS at about 90% of the VM, representing 585,000 IOPS. Now that we see both systems are running hundreds of thousands of IOPS, let's look at the disk latency differences under this simulated healthcare database. First, we demonstrate that UltraDisk is supplying near to 1 millisecond read times and almost a half a millisecond at write times. As for Premium SSD V2, we see that we are still delivering hundreds of thousands of IOPS with just slightly higher latency result compared to UltraDisk. Both disks give organizations of any size a choice and option to architect high-performing systems built for delivering electronic medical record databases, with UltraDisk being built for the most demanding and rigorous I/O environments.
Now that we have seen how latency can significantly impact an electronic health record's performance, it's important to remember that raw speed isn't the whole story. In mission-critical environments, operational efficiency is just as vital as performance. Azure not only accelerates your workloads, but also ensures you can recover and resume operations without delay. That's why we're extremely excited to introduce an important capability, Instant Access Snapshot. With Instant Access, you can immediately use created snapshots to generate new disk, eliminating the wait time that can often stretch into hours. When it comes to mission-critical tasks, time is non-negotiable. Delays of even minutes, let alone hours, are unacceptable. Instant Access Snapshot removes lengthy restoration processes, which empowers you to replicate your environment, to scale out your applications, or to roll back your system within moments. Let's see how Instant Access Snapshot can help replicate a hospital patient record system in seconds instead of hours, which is critical for healthcare organizations to safely and quickly troubleshoot issues without impacting production system. Let's look at the demo.
In this video, we will demonstrate how you can quickly restore your environment with Instant Access Snapshot, and that disks created from Instant Access Snapshots come close to full disk performance immediately after creation. Let's first walk through the difference of regular disk snapshots versus Instant Access Snapshots. First, we will create the regular snapshot of a large Ultra disk. Though this workflow is simple and straightforward, at the end you will see that we are unable to create a new disk from the snapshot. Now let's look at how Instant Access Snapshots have changed the game. Let's take another snapshot of the same disk, this time selecting the Instant Access Snapshot feature. You can see that immediately after snapshot creation, I can create a new disk. Once that new disk is created, I can replace the existing disk on my source virtual machine. This would simulate a potential application or data upgrade that failed and allow me to instantly roll back. After we have done all this work, let's go back and check on our regular snapshot. We still can't create a new disk. With Instant Access Snapshots, we can create a snapshot, new disk, and restore that disk to a virtual machine, all before the regular snapshots are ready to create a disk. Now let's step into how large disks created using Instant Access Snapshot provide great performance. This example shows how Azure eases the operational burden of large healthcare organizations, enabling their administrators to create full production copies of Epic Healthcare Database in minutes instead of hours. We will quickly show two different virtual machines using M176BS v3 VM that supports 650,000 IOPS, one that is running Electronic Medical Record EMR Database I/O Simulator with 12 Ultra disks attached, the source virtual machine, and one that is ready to accept newly created Ultra disks from Instant Access Snapshots, the cloned virtual machine. You can see our cloned virtual machine has no disks attached, and we will automate the Instant Access Snapshots, disk create, and attaching of these disks to the cloned virtual machine. Now that we have completed this, let's take a look at the cloned virtual machine's performance, which shows us near millisecond response times at around 500,000 IOPS under disk rehydration, when running the same EMR Database I/O Simulator as the source virtual machine. As we go back to look at our production database, the source virtual machine, we can see similar IOPS performance as the cloned virtual machines and better response times without disk rehydration. Being able to deliver great disk performance even when the business's data is going through high volume of data rehydration, Azure not only has opened up new options for managing large healthcare environments, but enables researchers and analysts to take copies of large datasets in minutes to advance healthcare research at an even faster speed than has ever been achievable before.
That's the kind of reliability healthcare providers, and frankly, many businesses actually require. In closing, what does this mean for you? Azure IaaS is built to power business-critical workloads across virtually every industry: healthcare, finance, manufacturing, and beyond. Backed by our deep investments in compute, network, and storage, Azure can help you run your applications with uncompromising performance, security, and scalability. Thank you for watching. And I know, with Azure IaaS, you're not just running workloads, you're accelerating innovation and driving your business forward. I am leaving you with a few reference materials for consideration and to learn more. Thank you for joining me today. Until next time.